All right, ladies and gentlemen, moving right along. Volume, what is the height? This is going to be similar to the lessons we did where we were finding a missing dimension. This time we're finding a missing dimension, the height, for volume questions. Students will be able to use the volume and other given dimensions to calculate the height of prisms. There's only one volume formula that we explored. Volume equals area of the base times the height of the prism. And we know that those formulas are specific to a three-dimensional shape because the B is capital and the H is capital. We're going to use what we know about volume and algebra to solve for the height. This is a rectangular prism. You'll notice that we've got the dimensions of the base, 12 and 4, but we're missing the height. In addition, we were given the volume of the shape. So it's kind of like we were given the answer and asked to go backward and find part of the problem. So first, we have to find the area of the base. Most people would say that the top is the easiest one to identify as the base. So if the top, the area of the base, is a rectangle, we're going to use length times width. So the area of the base is 12 times 4, or 48 meters squared. So now we're kind of stuck. We would like to do area of the base times the height, but we don't have the height. We can, however, set up a formula. Volume equals area of the base times the height. We know that the volume is 240 equals area of the base 48 times the missing height. Well, this side has multiplication, so we can divide both sides by 48. And we can find that the missing height is 5. Now you'll notice I've just got 5 equals h because I'm going to then say the answer, the height, is 5 meters. Notice it's only meters because height is a dimension, a single dimension. Volume was cubed because it was three-dimensional. Sorry, let me slide that over just a little bit. So the height is 5 meters. We don't want to just leave our answer here and say 5 equals h. This is like a word problem. We do have to go back and put our units in. All right, we've also got a prism with a rhombus or parallelogram base would follow the same set of rules. We would just use BH instead of length times width. The triangular prism, you'll notice they gave us the volume, and you'll notice that the height is missing. The nice part about this is that we really don't have to do a lot of work identifying that orange side because they've already told us which one it is. The area of the base, triangular prism, so the base is going to be a triangle, you guessed it. So here is the side that I'm going to use for my base. I am going to have to pull one number, however, from somewhere else in the picture. You'll notice that they gave me that this side is 4. Here's your right angle. They didn't give me this side. If I look to the back, this side is labeled as 3, so this side would be 3. The reason I need that is because I need the sides that make the right angle in order to find the area of a triangle. So area of the triangle, which is the base, is going to be 1/2 BH. So area of the base 1/2 times 4 times 3, the two sides that make up the right angle. The 5 is neither a base nor a height. If it helps, you can rotate the page, and now you can see base and height of the triangle are 4 and 3. So 1/2 times 4 times 3 is going to be 2 times 3, or the area of the base is 6 meters squared. Now we can substitute the base and the height that they gave us, the base and the volume that they gave us to find the missing height. So volume equals area of the base times the height. The volume they gave us is 39. Area of the base 6 times the missing height. Since that is multiplication, we're going to divide both sides by 6 and get 6.5 equals h. And then we'll just take a second and realize that we do have to write a final answer for this. The height of the prism is 6.5 meters. Again, that single dimension is measured in meters, which is one-dimensional, where the volume was given to us in meters cubed. All right, on the back, my paper's taken off on me. On the back, you've got a trapezoidal prism. So we have to have the formula for a trapezoid, and we have to be able to identify the parts of the trapezoidal prism. Most people, because you'll notice this little dashed segment is up here on the trapezoid at the top, most people would use that one simply because the height, the lowercase h height of the trapezoid is labeled on that one. We can pull the other number that we need. We've got our base 1. And this side right? These two are parallel. This side, base 2, we can get from down here, 1.2. All right, so area of the base is going to be 1/2. Let's see if I can get that just a little closer. Base 1 plus base 2 times the height. So 1/2, our base 1 and our base 2 are 2.8 and 1.2, and the height, that dashed one down the middle, 1.1. If I add the 2.8 and the 1.2 together, I get 4, and I can find half of 4 easily, which is 2 times 1.1, and I can get that the base is 2.2, area of the base, 2.2 centimeters squared. All right, I've got the area of the base. Now I need to get the missing height. The missing height labeled with a capital H. I can put that orange on there, but they already told us which one it is. They also gave us the volume. So, switch my pen. Volume formula stays the same. Area of the base times the height. The volume they gave us, 17.16. Area of the base, 2.2 times the missing height. Since it is multiplication, we're going to use division. Divide both sides by 2.2. And we would get that the missing height is 7.8. And then we would just have to make that little short sentence, the height. And I would normally do that as a capital. The height of the prism is 7.8, and I'll look over here, and it is centimeters. So that's it. Missing dimension is the height. Not terrible on volume. Remember, the volume formula much shorter, but you do have to use the correct area of the base formula for this to work. That's the big thing. Thanks, guys. Have a great day.